Measures of central tendency. So in measures of central tendency, we are going to discuss about a statistical analysis of a group of data. When the data is too large, we cannot represent the total data by every value, by representing each value. It is too difficult. If there are 100 values, we cannot say about that data using that 100 values. Instead of representing the total data with all values, what we are going to do, we are going to represent that one with single value. A single value which can represent the total data. That we can call it as central value. For example, in a class, one mathematics exam is conducted. After conduction of that exam, different students got different marks. For example, in a class 100 students are there, they got different marks. If you want to express that 100 students marks, what we will do, we will say one number. On average, in this exam, every student got this much marks. That one value represents that 100 student marks. That value is called central value. So this central tendency is useful whenever a large number of data is there. To represent the total large data, we require one value which represents the total. That single value is called central value. We sometimes say that average value. So that the central tendency discuss. That means a single value which represents total. In one word, a single value which represents a group of data or a large data. We can call it average or central value. This generally in our day-to-day life we see this. On average this much of strength came. On average this much of people are eating some type of food. On average. Instead of saying individual, we can say like this. In cricket also, a player's average will be displayed. For example, take a ex-batsman. He played some 100 matches. 100 matches scores is no need to say about that batsman. 100 matches scores average one value. That value represents. If we say average 40, that means on average he scored 40 in all the matches. That 40 represents 100 matches score. If a student write an exam, on average I may get this much of percentage in all subjects. Instead of saying each subject marks, he can represent one value for all subjects. I may get 60%. On average in each subject he may have 60 marks. That in our day-to-day life, knowingly or unknowingly, we are using this one, average one, central value. So here, the measures of central tendency, what we are going to discuss. In measures of central tendency, we are going to discuss about few. There are so many. These are all comes under measures of central tendency. Arithmetic mean, arithmetic mean, geometric mean, harmonic mean. These are all called central tendency. Harmonic mean, median, mode. Simply we can represent first three like this also. Arithmetic mean, geometric mean, harmonic mean. So generally these three, 1, these three. This one, this one. 1, 2, 3. Mean, median, mode. Mean, median, mode are called simple averages. We call these three as simple averages. Mean, median, mode. We call these two as special averages. Generally, we assume that central values means mean, median, mode only. Not only mean, median, mode, we are having two more, geometric mean and harmonic mean also comes under central values only. So come to the first one, arithmetic mean, EAM, arithmetic mean. Arithmetic mean means EAM, which is very simply we can say EAM means arithmetic mean is sum of items by or sum of numbers by number of items. Sum of items by number of items. What I am saying, if you have like these values, let x1, x2, so on, xn or n values, then mean is represented by x bar. Arithmetic mean, or simply we can say mean also. Mean we can call it as arithmetic mean. Mean is sigma I equal to 1 to n xi by n. This capital N is sum, or we can write here also sigma I equal to 1 to n ni. When this type of data is given, a series of data is given, we can call that one as discrete data. A series, raw data, simply 10 values are given, add 10 by 10, you will get arithmetic mean. For example, if you have data like this, data is given in this model x and f. X values are given like x1, x2, x3, and f values are given like f1, f2, so on like this. Then how to find mean? Arithmetic mean equal to sigma fx by sigma f. I equal to 1 to n fi xi. When data is in this form, x and f form. So when data is given like this, sum of items by number of items. When data is like this, we use this formula. When in data, if you find class intervals, with class intervals, grouped data we call this one as, this is discrete, ungrouped data, we call this one as grouped. When if you have a grouped data, that means 1 to 10 this many number, 10 to 20 this many number, 20 to 30 like this. If you have class intervals in the given problem, instead of here x, here you will have class intervals 1 to 10, 2 to 10 to 20, 20 to 30, 30 to 40 like this. When if you find the type of class intervals, there we use the formula for arithmetic mean a plus sigma f d by f. So I equal to 1 to n f I di. Here f means frequency is given, a is assumed mean. Assumed mean. N is sum of frequencies. N is sum of frequency. And d is deviation from assumed mean. That is x minus a by c. C is class interval. C is class interval, A is assumed mean, X is given values. Class interval means, for example, 0 to 10, 10 to 20, 20 to 30, class interval, 10 minus 20 minus 10, 10, 30 minus 20, 10. Upper limit minus lower limit. Like that you can evaluate C. A will be assumed mean. We will assume initially one mean. We will subtract every value of x from that. We will divide with c. That value we are going to multiply with f. We are going to find arithmetic mean like that. This is the series of data given. When frequencies are given along with series of data. When class intervals are given. Okay. Find arithmetic mean of following 2 bits are there. Coming to the first bit. So given data is this one. 8, 12, 16, 20, 22, 18. When raw data given, ungrouped data given, simply given some series of values, then we use the formula for arithmetic mean or mean. We say simply AM. Arithmetic mean means AM or mean. Both are same. Arithmetic mean AM equal to, simply we can say like this, sum of items by number of items. Sum of items by number of items, or sigma I equal to 1 to 10 xi by n, number of values n is. So here you can count how many values you are having. 1, 2, 3, 4, 5, 6. 6 values you are having. So n is 6. N is 6. Now you need to add all the values. 8 plus 12 plus 16 plus 20 plus 22 plus 18 by number of values are 6. If you add these all using your calculator, you will get 96 by 6. You will get 12.6 is average. Arithmetic mean of ungrouped data. So coming to the second bit, that is also ungrouped data when frequencies are given. So when frequencies are given along with x, frequencies are given, then arithmetic mean formula is sigma I equal to 1 to n fi xi by sigma f. You need to add all the values. So here fi xi means you need to multiply like this: 10 into 5 plus 15 into 2 plus 20 into 3 plus 25 into 10 plus 30 into 3 plus 35 into 2 plus 40 into 5 by these total values. Like this, what I am saying, like this you need to multiply. 10 into 5 plus 15 into 2 plus 20 into 3 plus 25 into 10 plus 30 into 3 plus 35 into 2 plus 40 into 5 by sum of frequencies. 5 plus 2 plus 3 plus 10 plus 3 plus 2 plus 5. So like this you need to do. Use your calculator to get the numerator and denominator value. The numerator and denominator value you will get like this. The numerator you will get 750. The denominator you will get 30. So 0, 0 cancel. You will get 25. 25 is arithmetic mean of given data for the second bit. For the first bit it was 0.6. Any doubts you may ask. Very simple one. When series of data is given, sum of items by number of items. When frequencies are given like this, we are going to calculate arithmetic mean like this. So calculate mean of the following data. Here class intervals and frequency are given. When class intervals or frequency are given, how to find arithmetic mean? When class intervals and frequency are given, then we are going to use two methods. One is direct method. Another one is shortcut method. How we are going to calculate mean in these two methods we are going to discuss now. In direct method, the formula to find arithmetic mean is sigma fx by sigma f, I equal to 1 to n. So this is formula, this we know very well. In shortcut method to find arithmetic mean formula is a plus sigma fd by n into c. N is sum of frequencies, d is xi minus a by c. A is assumed mean, c is class interval. I will tell you everything while calculating shortcut method. These two are formulas. Both gives the same results, same answer, but in this you may have some complex computations, difficult computations. When you have a big numbers, then this will be little difficult compared to this. Okay, so both gives the same results. Coming to the direct method, first prepare a table to get these all. Class intervals are given 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90. And also frequencies are given. Frequencies are 3, 5, 7, 10, 13, 16, 12, 8, 6. Next, we need to find x. X means mid values. Mid values, or we treat them as x. So these x values we will get lower limit plus upper limit by 2. 0 plus 10 by 2. 0 plus 10 by 2 is 5. 10 plus 20, 30 by 2. 30 by 2 is 15. If you can find two values, you can find remaining. You are getting 15 by adding 10 to 5. Like that you can add 10, 10, 10, 10. Our class interval is 10 minus 0, 10. This is class interval. 20 minus 10, 10. Add class interval for every value, you will get mid values. 15, add 10. 25, 35, 45, 55, 65, 75, 85. This is the only difficulty in direct method. You will have this much of lengthy values, big values. You need to multiply these two now, fx. So few you will get. Anyway, you are having calculator, you can use any method, no problem. So 3 5s are 15, 75 and 175, 350. Multiply these two. 10 into 35, 13 into 45. Like that you need to multiply. So now 10 into 35, 350, 13 into 45, 585, and 16 into 55, you need to multiply like this, 880, 12 into 65, 780, next 8 into 75, 600, like 6 into 85, 510. So you need to multiply these two, f and x. Next to find out the totals. For m, no need. Add these all. Using your calculator, you will get 85. Next, if you add these all, if you add sigma fx, 3970. Now, arithmetic mean is sigma fx by sigma f, 3970 by 85. You will get 49.625 using direct method. So this is the direct method. You can prepare table like this. You can calculate arithmetic mean in general way. How you have when frequencies are given, we calculate like that we are going to calculate. This is the direct way. Coming to the shortcut method, In shortcut method, the calculations are very easy compared to direct method. Table may be lengthy, but calculations are easy. We can easily calculate arithmetic mean without calci also. Very easily. At the end, we need to use calculator. So coming to shortcut method, same you have to write class intervals and frequencies, mid values. Along with mid values, you need to have di, that is xi minus a by c. This is x. And fd you need to find, f into d. Class intervals are given very clearly, 0 to 10, 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90. These are the class intervals given. Now frequencies also given. Frequencies are 3, 5, 7, 10, 13, 16, 12, 8, 6. This total already we calculated here, 85. And mid values also calculated. The average of these two, 0 plus 10 by 2, 5, 10 plus 20, 30 by 2, 15, add 10, 25, 35, 45, 55, 65, 75 and 85. So these are the mid values. Next, assumed mean we need to take one value among these. So generally we prefer the assumed mean, the middlemost value. This I am assuming as A. Assumed mean. So here 1, 2, 3, 4, 1, 2, 3, 4. This is middlemost. Any value you can take it as A. We will assume that mean first. That is assumed. You can assume any value, but we prefer the middlemost value. But here C is class interval 10. Assumed is 45. X is this one. 5 minus 45 by 10 minus 4. 5 minus 45 minus 40 minus 40 by 10. Next, 15 minus 45 by 10. Like that you need to calculate, but no need to calculate like that. So now we need to calculate di by assuming the mean is 45. If A assumed mean is 45, opposite to that value is 0. Under that value are positive values like 1, 2, 3, 4. Above you need to decrease. The same values you need to write in above with negative sign. Minus 1, minus 2, minus 3, minus 4. Okay, so this is the easy way of calculating di without using any calc. If you want, you can apply this formula also, you will get xi 5, a 45, 5 minus 45 by 10, you will get minus 4. 5 minus 45 minus 40 by 10, 10 4 0. Like that every value you will get, no need. Wherever you will write a, any value you can write a, but prefer middlemost value. A 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Now, multiplying these two are very easy compared to multiplying these two. In direct method, you need to multiply these two. You have to use calc to multiply these two. 13 into 45, 16 into 55, like that. But here, multiplying f and d are very easy. 3 4 are 12, 5 3 are 15, 7 2 are 14, 10 1 are 10, 13 into 0, 0, 16 into 1, 16, 12 2 are 24, 8 3 are 24, 6 4 are 24. Now add these all values. That means add my negative values and add positive values, subtract. Then you will get 37. This sum already we know. Here A is 45. Assumed mean is 45. Now the formula is arithmetic mean formula A plus sigma fi di by n into c. N is frequency. This is sigma fi di. A is 45. 45 plus 37 by 85 into 10. Class interval is like this. 10 minus 0, class interval. 20 minus 10, 30 minus 20. So now if you calculate this value, you will get same 49.625 only. The same value you will get. The difference is, this is easy to calculate. The table values are very easy to calculate. Here table values are little difficult. Here table is very simple. Here table is little lengthy compared to this. But calculating every column is easy. But here calculating fx need calc. Any method you can follow, both the methods are easy.